Okay, today I'm going to talk about the contents of section 1.4, which talks about the complex exponential. This is one of the most fundamental functions that we use over the complex plane, and its properties are worth going over more than once. So the book does a derivation of the properties of the complex exponential that's a little different from the derivation that I'm used to, that I learned when I took complex variables. We started with the Taylor series and worked up. But the book's approach is very valid. We start with kind of the minimal things that you need for the exponential function, and you show how it all must work. So what we want to have happen, we really want to have that the product of the exponential e to the a times the exponential e to the b should be equal to the exponential of a plus b, even if a and b are both complex. In order to do that, we're going to have to define the complex exponential in such a way so that that property holds. Now, in particular, this says if that property is going to hold, then we must have e to the real x plus I times the real y must be equal to e to the x plus I0, which is one of these complex numbers, plus 0 plus IY, which is the other of the complex numbers. So that must be e to the x plus I0, which is equivalent to the real number x, times e to the I times y. Well, we already know how to do e to the real number x. So now what we seem to have to define is e to the I times a real number. And that should be enough. We hope that'll be enough to give us our complex exponential. We also want to have it true that the derivative, the real derivative for a real variable t, d by dt of e to the rt, should be r times e to the rt, even if r is a complex number. We know that this is true if r is a real number. We'd like it to be true for r being a complex number. One final thing that we're going to use in making a definition of this part, this is all we've got left. One final thing that we're going to use in the definition of e to the iy is the fact that e to the x plus I0 really should be e to the x. And so that means e to the I times 0 should be 1. And it turns out that that's all we need. So if e to the I times 0 is e to the 0, which is 1, then that plus this is going to give us a definition of this.